A team of university students is building a spacecraft to chase down asteroid Apophis. This week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. On Friday, April 13th, 2029, asteroid Apophis will pass closer to Earth than our geostationary satellites. While NASA, ESA, and JAXA are all sending missions to rendezvous with the asteroid, a group of students at the University of Maryland decided to join the fleet. Their mission is called TERP RAPTOR, a CubeSat-based spacecraft that aims to fly by Apophis and snap images of the surface as it approaches Earth. 4 members of the team join us today to talk about how a graduate class project became a space mission, what they hope to learn, and why they're building a spacecraft from scratch before they've even graduated. Then Bruce Betts, our chief scientist, joins us for What's Up, where we'll mark the deployment anniversary of the Planetary Society's own CubeSat-based mission, LightSail 2. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. When astronomers Roy Tucker, David Tholen, and Fabrizio Bernardi spotted a new asteroid from Kitt Peak National Observatory in June 2004, they had no idea it was about to cause a global scare. The asteroid was named Apophis after the Egyptian serpent god of chaos. Within months, the asteroid was given a 2.7% chance of slamming into Earth in 2029. It was the highest threat rating any asteroid had ever received. For a brief, uncomfortable moment, the world had to reckon with the possibility that a rock roughly 350 meters across, about the height of the Eiffel Tower in France, might be headed straight for us. The energy of that kind of impact would be the equivalent of more than 1,000 of the most powerful nuclear weapons. It wouldn't be enough to end human civilization, but it would be enough to devastate an entire region of our world. Thankfully, follow-up observations ended up ruling out that impact in 2029. And radar tracking data during its flyby in 2021 confirmed that Apophis poses no threat to Earth, at least not for the next 100 years. But it's still coming really close. On Friday, April 13th, 2029, Apophis will pass just 30,600 kilometers above Earth's surface. Around 2 billion people across Europe, Africa, and Western Asia are going to be able to see it with the naked eye. This kind of event, a potentially hazardous asteroid that large passing this close without hitting us, it's estimated to happen only once every 7,500 years. That rare opportunity has drawn a fleet of spacecraft. NASA's OSIRIS-APEX mission, which is a repurposed asteroid sample return spacecraft, is going to rendezvous with Apophis shortly after its flyby. They're going to study how Earth's gravity will reshape its surface and rotation. And then there's the Ramses mission, which is being built by the European Space Agency and the Japanese Aerospace Exploration Agency. That mission is going to arrive to Apophis several months earlier, so it can observe the asteroid before, during, and after the encounter. And then there's the mission that we're about to talk about today. In the fall of 2024, a group of students at the University of Maryland sat down in a graduate aerospace engineering course taught by Brent Barbee, a planetary defense scientist at NASA Goddard. They set out to design a mission to Apophis, but what started as coursework quickly became something much bigger. They named their mission TERP RAPTOR. It stands for the Terrapin-Engineered Rideshare Probe for Rapid Response Asteroid Apophis Profiling, Tracking, Observing, and Reconnaissance. Man, I love space acronyms. TERP RAPTOR is now an official University of Maryland initiative, aiming to build and launch a CubeSat-based spacecraft to image Apophis during its close approach. CubeSats are miniature spacecraft built to a standard size. A single unit is just 10 centimeters on each side. They're designed to make it cheaper and easier for universities and small companies to fly spacecraft. Today, we're joined by 4 members of the TERP RAPTOR team. Adrienne Rudolph, who's the Student Principal Investigator. Elena Wu, the Lead Project Manager. Tyler Autrey, the Mechanical Structure and Material Lead, and Xander Williams, the Propulsion Lead. Here's my conversation with the TERP Raptor team. Hey, everyone. Thanks for joining me.
Thanks for having us.
Yeah, thank you.
Thank you.
Thank you.
Adrienne, I understand that this whole thing started as a graduate course project. At what point did this go from a class assignment to, we're actually going to try to send this to space, you guys?
Yeah, so it was either during our preliminary design review or our critical design review. I can't remember which one because it was almost 2 years ago. But we had a couple of reviewers from NASA Goddard come and review our mission development. And one of them said, this could actually be a real mission. This could be feasible. And I think that kind of clicked for the team. And we were like, oh, okay, well, maybe we should try this. And so we wrote a paper and we submitted it to the SciTech conference in Florida. And we also were invited to come speak at the NASA Small Bodies Assessment Group meeting, also in Florida, the same week. And so we got to talking about the mission, and there was a lot of interest in it. And that's kind of when we decided to go forward with it and see what we could do with it.
For people who are completely unfamiliar with this concept, what is TERP Raptor?
So TERP Raptor is a CubeSat mission to an asteroid. And that asteroid is Apophis. Apophis is roughly 350 meters in size, about the size of the Eiffel Tower. And it's going to be making a very close approach with Earth on April 13th of 2029. And so we have designed a mission to go out to the asteroid a couple of months ahead of its close approach and take images of it and take some other measurements of it. And like I said, it's been in development for almost 2 years now.
What I love is this name. I'm never going to forget this, TERP Raptor. What does that stand for, and how did your team come up with this name?
TERP Raptor stands for the Terrapin Engineered Rideshare Probe for Rapid Response Asteroid Apophis Profiling, Tracking, Observing, and Reconnaissance.
I gotta say, space people love their acronyms, but that is like Osiris Rex style acronym.
Yes, exactly.
Our professor was the one that came up with it. He and a couple of other professors over the summer before we had our class had come up with the idea, and they came up with the name, and that's how the idea to pursue an Apophis mission came up.
Is it true that the TERP is a reference to your school mascot animal? I'm not sure if that's real.
Yeah, It is. The terrapin is our mascot. Testudo.
But man, I love that all of the missions that are going out to these asteroids evoke like animals or giant birds, right? You got some really cool ones on the way there. And Elena, as the lead project manager for this mission, what does the day-to-day look like for managing a mission of this size?
When I first started freshman year, which was only a year ago, actually, I did not expect I would be working on a space mission. But for me, during the semester, I balance it with my classes. So I'll go to class, I'll go do my homework afterwards, and then I'll go work on TERP Raptor for a couple hours. And it's a lot of meetings because I'm a project manager. I'm always meeting with our technical team. I'm also meeting with the business team and the admin team because we have, unlike many other CubeSat programs, we actually have a business and admin side to help us with funding and with our media efforts. And so it's a lot of meetings throughout the week. Weekends are my go-to day for working on TERP Raptor. And now over the summer that I'm working a full-time internship, it's been a lot harder to make time for TERP Raptor, but I still can put together an hour or two every day, just work on it and keep progressing. And then on weekends, I just keep working on it full-time.
Being a student, and especially when you're a grad student, is a wild amount of work. So adding this on top of everything is just a lot. Elena, how many different students are working on this project, and how do you work with faculty to put it all together?
So we have a lot of fluctuating amounts as people graduate and people join the team. Usually it's around 25 to 30 students on the team. And we also have 5 UMD professors. They know so much more than us. They have so much experience. And so we go to them for feedback on our mission and any questions that we have. And it's just a super overall great experience for everyone.
Well, you only got a few years. We're looking forward to April 13th. I should say Friday, April 13th, not to be superstitious about it, 2029. Adrienne, for people who haven't heard about Apophis, why is this such a big moment, not just for people who want to launch missions to space, but for people who are interested in planetary defense?
I think Apophis is interesting to everybody for different reasons. The fact that this asteroid, something of this size, of this composition, coming this close to our planet, space is huge, right? You say it's astronomical, haha, but it is. And so for something to come this close is unreal. It's incredibly rare. And so being able to look the beast in the eye without actually being affected by it is spectacular. And so I think people all across the world are going to want to see it. And speaking of, approximately 2 billion people across Europe and Africa and West Asia will be able to see it in the night sky. It'll look like a star going across the sky on April 13th. And in terms of the scientific community and those of us in planetary defense work, typically when we design missions, we have to go out to an asteroid and design a really expensive flagship mission to go out there and study it. But this is coming to us. It's coming to our own backyard, our own neighborhood. And so it's a perfect opportunity to gather up enough people in a short amount of time and put together a spacecraft really fast and stick some instruments on it and go out and take measurements of the asteroid. And whenever it was first discovered back in 2004, we had some radar imagery of it. And the shape of it and the size of it and what it's made out of are still pretty uncertain. And so when you have uncertainties, you want to go and make those more certain. One of the most critical parameters that we want to know about asteroids in case of the need to mitigate or deflect or disrupt an asteroid in the future, if it were on an impact course, is to know its mass and its density. So that way you can properly design a mission to take it out or knock it off course. And so that's one reason why we really want to study Apophis, because it's coming straight to us and it's a perfect opportunity to go look at it.
Yeah, how weird is that we just happen to be at this exact place in time for this to be that close? I mean, it's literally coming closer to us than our geostationary satellites. I keep saying that I hope it scares a bunch of people, but I don't honestly want people to be horrified. I think this is just a really interesting moment for people to be engaged in something that we need to be mindful of. People have said it before, and I'll say it again. The dinosaurs didn't have a space program, right? How lucky are we that we get a moment like this to truly analyze something that maybe at some point in the future, maybe might actually intercept our planet?
I think it makes people face their mortality. We are hit by small things all the time. We had Chelyabinsk back in 2013 that hurt and injured people in Russia. And while we're not hit by big Apophis-sized things all the time, we're probably due for something that big sometime soon. And scientists don't know exactly when that's going to be. So it's kind of a warning sign, if anything. And I think people do and should see that.
Well, thankfully, there are many different space agencies that are taking an interest in this, right? It's not just you guys, but also the European Space Agency, the Japanese Aerospace Exploration Agency. You've got OSIRIS-REx being turned into OSIRIS-APEX, so NASA's getting involved. But it's really interesting to see something like this come along. You're a small university-led CubeSat mission. What is it that you guys are hoping to contribute along with all these other missions so that we can all work together to understand this body?
So the very special thing about TERP Raptor is that UMD has never put anything in space before. So this is the very, very first time that we're going to be putting something up into space. And on top of that, we'll be getting hands-on experience actually putting something in space. We'll be the first group of students who get to learn what it takes to put something up there.
But it does take a lot to put something up there. Like, the Ramses mission that the European Space Agency and JAXA are putting together is going to be following this thing for quite a long time, but you guys are just going to be clipping right past it, right? So how fast are you guys going to be going by this object when you finally rendezvous with it?
We'll be going roughly 2 kilometers per second during our flyby.
See, that's really challenging because it means that you have to capture all of that stuff in a very short amount of time. What is it that you guys are hoping to gather scientifically during such a short flyby?
So scientifically, we're looking at the size and shape of the asteroid, as well as relative ages of its surface. So depending on what kind of craters and how many craters and what size boulders there are, you can kind of date or understand the age of parts of the surface. And we're also looking to demonstrate the very first high-speed flyby mass measurement of an asteroid, which has never been done before. So it won't just be our CubeSat. We'll actually be going up there with a host spacecraft. Cool.
So do you guys know what host spacecraft that's going to be at this point?
Yes, but we cannot tell yet.
Ooh, secret. I love that. But I mean, it's an interesting point that like you are basically hitching a ride with another spacecraft at some point in the future. You're doing a ride share. It's literally in the name of the TERP Raptor. So what has that process been like to try to find this ride share? And do you know how you're getting to space yet?
So in the very beginning, our mission was actually quite different from what it's become today. So at the very beginning, we thought that we would have a satellite that would go all the way up to GEO, and then we would just hang around Earth until Apophis came, and then we would go change the trajectory and then do our Apophis flyby mission. But that also requires finding a very expensive rideshare to space, likely on SpaceX, because geo options are just so limited. However, in spring semester, we found out about this opportunity with our current host, who would take us not to geo, but they would take us all the way out to interplanetary space right before Apophis comes. And so we have a ride to interplanetary space, but that also changes our entire mission plan. We had to downsize from a 16U CubeSat to a 12U in the span of one semester. And we also had to remove one camera. We originally had 2 imagers. Now we're at 1. And we had to downsize. I'm sure Xander can talk more to this, but our propulsion requirements and a lot has just changed in the past semester to accommodate this plan.
That answers so many of my questions because I was reading through the paper and then reading other things online. I'm like, many of these things have changed, but that makes sense. I mean, this is a rapidly changing situation. So that's actually really interesting to hear, but sad to know that you're going to have to remove one of the cameras and limit the propulsion systems. And I'm interested, Xander, like the original plan was to get from GEO out to, a little bit further away in order to meet this asteroid more effectively. How does that change your propulsion needs and what you're going to be doing during this actual situation?
So luckily with our new trajectory, even though we had to downsize our spacecraft, we also were able to greatly downsize our delta V budget, which is pretty much this measure of, I guess, like the performance that's required of your propulsion system. So we went from having a requirement that was it was above like 40 meters per second, and now we're down to something that's around like 2 meters per second at the maximum. And so that allowed us to greatly downsize our propulsion system from sitting around 4U to now we're looking at a system that's called 0U, because in a deployer, it's common for them to have carved out spaces that they call tuna cans because they're circular and cylindrical. And so the propulsion system we're currently looking at, it's shaped like a tuna can. So you can actually attach it to the end of your CubeSat and then sit that in the deployer. So technically it takes up 0 U's of the CubeSat. So it was actually not as big of a problem as we originally anticipated to downsize our propulsion system. And it was really cool to get to look at a bunch of different smaller systems and consider them.
That is an interesting thing, though. I mean, like, so much changes around that. Tyler, if you're downsizing this spacecraft, are there any concerns for, say, like radiation shielding or how this spacecraft is going to react now that you've made it so much tinier?
Yeah, so initially when we had our 16U, we did there was analysis for radiation, and when we were doing it for GEO, we had to do an initial analysis for the radiation. And so when we changed our trajectory to deep space and we were minimizing it, one of the big upsides was that weight-wise, we could add more shielding if we needed to, because now we're going in deep space. But then we have to redo our analysis to get those correct numbers for the radiation. One of the benefits is, though, because we downsized, there's a lot more space internally. So we can, one, add more radiation shielding, as well as, like, for the tuna cans, there's no worry that there's going to be any interference with those compartments or components.
Man, that's wild that so much has changed in just the last few months. I'm sure that's, added to a lot of the pressure that you guys are dealing with. At the same time, though, I'm happy to know that it sounds at least that you've figured out a bit more of how you're going to get this thing to space. Although it's still secret. Do you know when we might know when this thing is going up, who you're going with, and more what the trajectory is going to look like?
So when we're going up, we are planning to hitch a ride with our host and launch around June of 2028. And we would be coasting through space for about 6 months until we encounter Apophis at the end of December of 2028. We do know that we have lab space approved at NASA Goddard, so we will be building our CubeSat there. And we have signed an MOU with our host. We've signed an MOU with a partner university, which we'll also be revealing soon. We've also started separate conversations for testing facilities with the Aerospace Corporation. So there's a lot that's happening. We're beginning procurement. We got a pretty large in-kind donation recently to go towards our longest lead items, so our imager and our solar panels. So yeah, we're buying stuff. We got lab space. We are ready to go.
But this is one of those things where you're asking for people to help fund a project, doing something that no one has ever done at a university where no space thing has ever been launched before. And the Planetary Society has like a little bit of experience with this because we launched a CubeSat-based project called LightSail and LightSail 2. And it was the first all crowd-funded spacecraft in the world. And I imagine you guys are having an interesting kind of similar conundrum trying to get people involved in this. Who are you turning to try to get funding for this project? And how can we all help make this thing happen?
I can speak to funding a little bit. So we obviously need a lot of money to get to space. Our hardware cost is $1.2 million, and our integration cost with our host is around $2 million. And then there's just a ton of overhead because we're planning to onboard a couple of full-time engineers. So a lot of money that we need. And so we've been very lucky to have some major donations from NASA and some of our other partnerships. And in addition to that, we actually have a crowdfunding platform called Launch UMD, which is where we've been raising some money, around $23,000 so far.
That's amazing. I mean, honestly, if you get loud enough about it, we had to get 55,000 people involved to launch LightSail. But I mean, for something like Apophis, I think we can get some people excited about this. It also sounds like the price of the mission has come down quite a bit since your last paper was published. I want to say that ballparked it at around 15 or so million. Is that right?
Yeah, we brought it down significantly. Getting the ride share with our host and downsizing our propulsion system and taking out the camera and making things smaller has seriously brought that cost down, which our university leadership likes, which we like, and it makes it a lot easier to crowdfund and get people behind the mission.
So originally you were planning to have 2 cameras on this spacecraft. Now you only have 1. And I understand that the cameras had kind of different functionalities. How are you going to get equivalent science with just 1 camera?
So we won't necessarily be getting equivalent science with just 1. Originally, we had both cameras because one of them is more about looking at the surface structure and the boulders and craters and just what does the asteroid look like. And then the other camera was supposed to be looking at the spectra of the asteroid. So Apophis is a stony asteroid type, and the scientists think that it's high in olivine and pyroxene. I hope I'm pronouncing that right. And you can't see those with just a regular black and white camera. So we were hoping to get that extra spectra of the surface. Honestly, the most important one is the one that we have. So we're still going to be able to hopefully successfully meet all of our science goals.
Yeah, it'd be really useful to have some kind of spectral data, but since we already have 2 other giant spacecraft that are going there that are probably going to get equivalent data, I think the most important thing is really getting that kind of vantage point on it that's different from what Ramses is going to be getting, because if you can look at it from different angles, like that's the real science that's going to be useful. But it also sounds like you're changing the timeline here, right? Like you were originally going to rendezvous I think closer to the time that it's going to be getting toward Earth, but now you're planning to get to it around December, right? So how does that change what you can learn from this object based on where it is relative to Earth?
If we go before the asteroid encounters the effects from Earth, then Ramses will be able to validate, and OSIRIS-APEX will be able to validate some of the data that we come up with. So if the asteroid during its Earth close approach is supposed to be changing, if its rotation rate is going to change, if its trajectory is going to change, if the surface regolith is going to be moving around, Ramses is going to catch that. And so we will have the before, Ramses will have the during, and OSIRIS-APEX will have the after. So we'll get the full story of Apophis, which is the point, and we hope to coordinate with the other missions. We have started talking to the Apex team.
Oh, that's a lot of fun. You get to coordinate with other missions on this. Oh man. Have you guys tried to engage with the Ramses team as well?
We tried talking to them, but they're pretty full with other, I think they're taking some other CubeSats along with them, and they're working with JAXA, and they only have so much money and so much time. So I assume that as we go forward and we know more about our mission, that we'll be in regular communication with them about sharing data. But as of now, we're not really working together.
So Tyler, I have a conceptual idea of how big CubeSats are because, we've got a model of our spacecraft in our rotunda in HQ. But for people who aren't familiar with CubeSats, how big is this thing actually?
Yeah, so you can think about it as basically having like a 1U, right? So the unit is a 10 by 10 by 10 centimeter cube, right? And so our 12U CubeSat is basically you're having those 12 units basically in the size of like a microwave, which is around, on the top of my head, 226 by 226 by 340 millimeters. But you can kind of think of it as you get like a large microwave to fit like, your hot pockets in. That's basically the kind of size that you're kind of looking at for this 12U.
So you've moved the propulsion system such that it's not going to take up like a U by itself. But how do you fit all the rest of the things that go into the spacecraft in that tiny little size?
Yeah, so one of the biggest benefits is that a lot of our components is kind of made to be in these like small form factors. So like the Mantis imager or the imager that we have is going to be able to fit in that size. And then for our propulsion systems, like you mentioned before, is that 0U, but even if it was inside, it's still even smaller than a unit itself, right? So we've been kind of in a good position to where we don't have a large amount of components where we have to fit in and really work with not a lot. We're kind of blessed to have a lot of space to work with. So it makes it a little easier when we're doing a lot of like our assembly and integration and kind of figuring out, where do you want to put this? Is the best place to put it here? So that's kind of made my job easier, but it's been a real blessing.
It sounds like the speed at which you're going to be going by this object now is lower than it used to be, right? Does that mean that you're going to be able to take more images and get more data while you're actually flying by this object?
Ideally, yes. That is the plan.
So how many images are you projecting that you're going to be able to get?
Based on the integration time and frame rate and all that jazz of the imager itself. At max, maybe 1,000 images, just with how fast the frame rate is. But that's also if we're imaging the entire asteroid. And I'm betting that we're not going to be able to do that because we don't know exactly which way the asteroid is going to be pointing. So we might get the short end of the stick. We might get the long axis. Who knows? So enough. I will say we will get enough images.
I was reading that the original plan was, you were going to get way less images and then try to downlink maybe up to 3 of them as fast as possible. Is that still the plan, or are you going to try to send it all back at once?
We're probably going to be downlinking some of it over time. We will be communicating with our host spacecraft, so we're not going to be communicating directly with Earth. So we'll have to send our data packets to them, and then they'll have to send them back down to the ground. So I expect that it'll take some time.
We'll be right back with the rest of my interview with the TERP Raptor team after this short break.
Hi, Bruce Betts here, Chief Scientist at the Planetary Society. Our organization is strongly committed to defending our planet from an asteroid or comet impact. Thanks to the support from our members, we've become a respected independent expert on the asteroid threat. So when you support us, you support planetary defense. It's a lot to do, and your support is critical to power all this work. That's why we're asking for your help as a planetary defender. Together, we're advancing the global endeavor to protect the Earth from asteroid impact. Imagine the ability to prevent a large-scale natural disaster. You can be part of this global effort. A gift of any amount to the Planetary Society helps keep this critical search going, protecting our planet and everyone on it. Visit planetary.org/Defend Earth to make your gift today. Thank you.
My understanding is that originally you guys were going to be using like a GPS system to actually figure out where this object is, which is already complicated because you were going to be above the geostationary satellites. So how are you now going to be tracking where the spacecraft actually is while it's in space?
I have a little bit of understanding because I was talking to our ADCS lead, Trinity. So she was saying that we would have a star tracker that would be helping a little bit with that type of navigation.
And there's just a star tracker, but is there also still going to be a sun tracker as well on board, or did you have to throw that out for space?
The sun sensor is built into a different component that we're looking at for our ADCS system.
Cool. Although still complicated, what is on board that allows you to actually point the spacecraft?
In addition to, I guess, the star tracker, we also have reaction wheels. And so the reaction wheels will be causing the changes in the actual pointing of the CubeSat. And when we need to point it at Apophis, we're able to do that with those reaction wheels. And then if we have to point it for the solar panels, we can also do that as well.
So that's how you're going to actually turn the spacecraft, but what are you using to propel the spacecraft? And I'll throw that at you, Xander.
So we're using these water-powered thrusters, and the cool thing is that we can actually use a water-alcohol mixture, because at first we were concerned about sending water up into space and it freezing and popping the tanks. Though with the alcohol mixture, they can go down to -30 degrees Celsius and still not freeze. And so the idea is that we're going to use 4 of those. At first, we were trying to get away with only 2 just to bring costs down, but we need a way to desaturate the reaction wheels. And so we need to be able to have both control over roll, pitch, and yaw.
That's interesting. Why not use kind of more classic rocket propellants on the spacecraft?
Our first system, the 4U system, was going to use hydrazine, and that presented a problem of that you have to go through a long process to export that. And so in order to avoid any type of complications with importing and exporting, we decided to go with a safer propellant of like water. You don't have to worry about it exploding or anything like that.
So if you have 4 thrusters on board, what happens if any one of them goes out, or if one of the propellant tanks freezes on accident? Like, it's really cold out there.
So luckily with having 4, it does give us a little bit of redundancy in the case of an emergency. The only problem is that now the reaction wheels would have to be a part of their own desaturation. So as a result, we wouldn't be able to allow them to fully saturate before trying to do the desaturation maneuver. And so, like, if something happens, like if some stray object comes at the spacecraft, it does pose a risk of, like, okay, if the reaction wheels are already saturated past a certain point, if we start to spin out, they may not have enough momentum left to get us out of that type of spin, which would be rare. And also, we're hoping that all of our thrusters remain active. So hopefully something like that won't happen.
Yeah. I mean, this is like a one shot, once in a lifetime situation. If something goes wrong, I mean, that's just kind of like space is hard, but fingers crossed. But you do bring up an interesting point, right? I mean, what is the actual outside of the spacecraft made of, such that in the event of a, micrometeoroid or something like that impacting it, is the whole thing going to fly apart? Like, what's the plan there?
Yeah, so the plan currently is that we would be having some level of like aluminum sheets surrounding the CubeSat frame. And then that would also protect from the radiation as well as the MMOD. So currently we're doing additional analysis to see how thick we need to have that shielding, and then what other additional things we can have that are also decreasing the risks in terms of catastrophic intersections with like MMOD.
What kind of testing are you guys planning on doing on the spacecraft to make sure that it, say, doesn't resonate itself apart during launch? Or, what can you do to actually figure out whether or not this thing is going to work when it gets to space?
Yeah, so I can kind of speak on from the structural testing. So a lot of the literature that I've seen from like launch vehicles, that there's a good amount of like testing you have to have for your CubeSat and for your satellite before you give it to the launch provider. So for us, we'd be doing a lot of vibration testing, of course, shock tests, temperature and vacuum testing as well. And also looking at what are the ratings for the radiation of the components to give that there, as well as looking at force. So like looking at the lateral and axial G forces that are on there. Those are the ones off the top of my head. Of course, there's going to be a multitude of more, because there's no such thing as too much testing. So we're also trying to make sure that everything is up to the standards of, things that are being put up by NASA or any of the larger space competitors.
It's got to be a challenge to manage all of that. But, each and every facet of this mission is challenging. And I'd love to hear from each of you what the most complicated part of this so far that you didn't anticipate was. And I'll throw that at you first, Adrienne.
I think the most challenging part that I have encountered is relationships. I have had to play the middleman between NASA, between our university, between our other university partner, between leadership at our university, between procurement and business, and between our commercial partner, and making sure that everybody's on the same page with everybody else, that everybody is just as convinced as everyone else that the mission is feasible, that everybody's on the same page about the design. It all comes down to relationships. And over the last 2 years, that's the most important thing that I've learned.
Yeah, it's always the human relationships. We always think of these spacecraft as just, these robots in space. But what I've learned doing this job is that it's always about the human stories behind it that makes it so much more complicated.
Definitely.
What about you, Tyler?
For me, the hardest has been just the fact that this is something that hasn't been done before, right? So usually when talking about projects like launching a satellite, you have things that are very similar. So you have like CubeSat programs, you have things of that nature. When you're talking about, a college trying to put up, or a team of students putting up a CubeSat, there's not a lot of heritage for it. So we're trying to navigate a lot of the technical side, or even like Adrienne was saying, the relationship side. There's not a lot of literature or anything you can kind of look back to. So you're kind of being the pioneer in terms of trekking the way of making, new CubeSat program at UMD.
Yeah, you guys are definitely pioneering at this point. But I mean, that's the great thing about CubeSats. I think that this functionally is the exact reason why CubeSats were invented, to give this kind of accessibility to smaller organizations like universities in order to do this kind of work. So I think it's helpful not just to go through the process, but hopefully to document it so you can then reach out to other student groups and see how you can help them. How about you, Xander? Because I feel like the trajectory of this thing has changed so rapidly that you've probably dealt with some really unique challenges over the last few months.
Having a short timeline for this mission because there's this asteroid coming, so it's not like we can delay or postpone, has been an interesting challenge to overcome, especially with looking for propulsion systems, because sometimes it can take a vendor up to 2 years, but 2 years we need to be already launched and in space. So it's been also a fun challenge because you have to think outside the box now, because you think you found something perfect, but it's going to take too long. So now you have to find something else that maybe hasn't been used in like the way that we're intending to use it before, but making that work and finding a way of bringing the entire system together.
Well, Adrienne, you were just talking about the complexity of human relationships, but I'm thinking about how that adds to your workload, Elena, because things keep not only changing between people, but people are graduating as you're moving on with this project. How do you deal with transferring information between people who are rotating in and rotating off of this project?
Yeah, so a huge part of our mission that we are trying to drive home a lot is documentation. Document everything you are doing. Otherwise, we researched this. The number one killer of university CubeSat teams is actually just member turnover, people graduating, people leaving, and then, well, who's next? Nobody knows. And another thing is mentorship. So we have a lot of leads who are very smart. And the previous lead project manager, too, he was super smart. And he's taught me a lot. And I'm sure the leads have taught their members a lot, too. And sort of just this mentorship so that our program can keep going and going and going.
That's always the thing, right? And you've got to keep that context. And we're seeing it even right now at places like NASA with the amount of people that have left in the last year. It's almost about 1/5 of all NASA workers have left in the last year. And that knowledge transfer is super, super important. And you guys are dealing with it in microcosm very rapidly. So what are you all hoping personally that you're going to learn about Apophis or about spacecraft in general through doing this? I mean, I'm most excited to see how this thing changes as it goes by Earth, but I'm curious to hear what you guys are all most motivated about as you're like leading up to this mission.
I have two visions in my mind of the most wonderful part of what this mission is going to become. And the first part is I always imagine launch day. I imagine myself next to my teammates. We're all like shoulder to shoulder next to each other, watching the rocket go up and thinking, even if the rocket doesn't turn on, or even if the CubeSat doesn't turn on, that's still mission success because we've never built a CubeSat before. And we did it, and we put it on a rocket, and it's going to space. It's going somewhere. So that's the first part that I'm really looking forward to is setting that foundation for the next generation of UMD students that come through and want to build something. And then the other one is seeing that, having that first image of Apophis come back and showing it to the world and saying, hey, this is the rock that we have known about since 2004, that we've been hyping up since 2024. And I'm already just incredibly proud of this team as it is. They put in so much work. I can't wait to see where this goes.
How about you, Elena?
For me, this mission is sort of like, I won't say it's the peak because that might limit me, but it is certainly an apogee, to put it in space terms, of my undergrad career since Apophis comes in 2029, which is my senior year. So it's certainly very exciting. And as Adrienne mentioned, I also cannot wait to see what this asteroid looks like in person. Imagine taking 4 years just to take a single picture. And the other part about this mission is I've already learned so much already, and we're only in our first year. I know I'm going to learn so much more. So in the past year, I came into university totally thinking that I wanted to go build airplanes someday. But now I know I want to do space through this mission. And so I'm just excited to see where I'll go through TERP Raptor.
Yeah, that's going to be wild for you. It's going to be April. You see this thing go by, and then like the next month, you'll graduate. How about you, Tyler?
I guess piggybacking off everybody else, kind of saying, having a successful launch would be great, fantastic. I think one of the other, personal things that I'm kind of looking forward to is, like Elena mentioned, the experience. So going into grad school, I did my undergrad in mechanical, and I didn't have a lot of aerospace experience. So one of the things I wanted to do when I was here was make most of my time to get experience. And this is going to be the epitome of the experience you can kind of have, which is actually getting your hands on making something that is actually going to space and saying, yes, I put something up there, even if worst case scenario, fingers crossed, it doesn't do what we want it to do fully. We did put it up there. We know how to put something up there if we need to do it again. So having that experience, and then putting that forward in the rest of my career is going to be something I'm looking forward to. And, also just ushering in new students coming into this program. So Elena mentioned it before, where the turnover rate is really high. And if you're not documenting everything down, then that can be a real issue in, this program dying. But I don't want this to go anywhere. I know everybody on the team doesn't want it to go anywhere. So I'm kind of doing my part in documenting everything I'm doing, writing everything down as a leader. What do I do? What do I think about? How do I think about these things? So that when I graduate, I know that someone has the skills, the resources to become a great team leader, to do better than what I did when I was a team lead, and move this program forward.
It's very Isaac Newton, standing on the shoulders of giants, I love that.
Yeah.
All right. How about you, Xander?
For me, it's really cool to work on a project where it's going to launch within a couple years and be able to contribute to the scientific community. Because the research that I do for my PhD is low technology readiness, since I work with nuclear fusion systems. So the joke is fusion's always 40 years away. So it's really cool to work on a system that's only 2 years away from having a direct impact on the public.
Man, can you imagine what we could do in space if we had fusion tech all figured out? It'd be amazing. Well, last question, and I'm going to put this to you, Adrienne. This is a first of its kind mission. You're doing this at the university level, and clearly things are changing and it's very complicated, but I can see that this has made a big impression on all of you and everyone that's worked on this. It's even changing the trajectory of your careers. What would you say to students at other universities who would love to start a program like this, but just don't know how to get started?
I have an answer. I'm trying to keep it civil. I would say, even if your professors or your university leadership or your parents or your peers say that you can't do it, you go out and you do it anyway. You go do it anyway. You don't ask for permission. If you have to build the darn thing in a garage, go do it. If you have to go and talk to 1 million people to make $100 to buy one tiny component, do it. Start. Because what I've learned is that everybody talks until you actually do it. And we have needed a CubeSat program at Maryland for years. And by God, we're going to start one.
I love that answer so much. If I had listened to every person who told me not to do what I was going to do, my life wouldn't have been at all the same. And this spacecraft wouldn't be as close as it is to trying to get to space. And that's so true of so many people in the space community. I think all of us have really, really big dreams, and they seem really unapproachable when you first look at them. But all you really have to do is start and do the thing, and you never know where it's going to lead you. I wish you all so much luck as you try to do this. I know you've got a lot to do in the next few years. And trust me, I'm going to check in a few years and see how this is going, because I think I and everybody else in the space community is really, really looking forward to Apophis. And the more people we can get in on something like this, especially for the future of planetary defense and even just the future of universities building their own missions, it really bodes well for the future. And I'm so glad to hear from all you guys that you've had such a great experience working on this and that you're making such amazing inroads on getting this whole thing done. So I really appreciate you guys being here.
Thank you. Thanks for having us.
Thank you so much.
Thank you.
Thank you.
If you'd like to follow the TERP Raptor team's progress or help them actually get to the launch pad, you can find links to their donation page and social media on this episode's webpage at planetary.org/radio. Now, let's check in with our chief scientist, Dr. Bruce Betts, for what's up. We'll be marking the anniversary of the deployment of our own CubeSat adventure, LightSail 2. Hey, Bruce.
Hi, Sarah.
I understand you've had a really busy week. You have been moving. How's it gone?
Yes, well, anyone who's moved knows no matter how well it goes, it's not going well. It's gone fine, but it's been exhausting, and I can't find parts, which is why my microphone's sitting on a couple of socks right now. It's somewhere in a box. There's the appropriate stand for it.
Well, I hope you find it eventually someday after some rest. But so this week I spoke with the TERP Raptor team, and you were actually the one who connected me with them. How did you first meet those people?
Well, their advisor, Brent Barbie, who he and I have been working together on planetary defense related things for at least 20 years. So Brent and I go way back, and he's one of the key organizers of the Planetary Defense Conference every couple of years. So Brent's involved with this heavily, obviously, and then they have the students involved. So one of their students and Brent came out and met with me at the Planetary Society to talk about the mission they hope to fly. So exciting. I hope they can pull it off, because they've got a lot of challenges, but it's a good college try, literally. It's great that they're doing this, and I hope it works out great. And we had a CubeSat once, and it worked out quite well. So
it did. I mean, their CubeSat mission is definitely bigger than ours, but I was trying to compare the size of LightSail 2 while I was talking to them to try to figure out how big theirs is. So ours was I don't know.
I actually don't remember how big theirs is. So
it's a 12U.
Oh, well, yeah, that's, sure, if you're going to encounter an asteroid and be all, have lots of space and lots of mass, that's like, ours was the 3U, and it was the size of a loaf of bread. So they have 4 loaves of bread.
It's funny because I actually ended up interviewing them on almost the exact date of the anniversary of deployment of LightSail 2, which was like just last week on July 23rd. So the timing was kind of perfect.
Yeah.
What was that deployment like for you? Because I mean, after all of that work, that must have been honestly, it must have been really tense, very scary to not know whether or not it was going to work.
Yes. In fact, just you saying that brings back nerves. Yeah, it was tense. We had a really great team. By that point, we were down to our core, just basically our core team of 5 or 6 people at that point, and trying to fly a solar sail mission with a CubeSat, a small spacecraft, and demonstrate controlled solar sailing. So if you don't deploy well, if you don't deploy at all, if you deploy all crookedy and messed up, you don't have a mission for our goals. So years and years and years of effort by lots and lots of people went into, and far beyond that core team, went into that moment. So to watch the indications that came in a little bit at a time. So even the first thing was, besides communication, you get a communication, and then you hope the motor count goes up on the motor that spun it out. And then you hope it goes to a number of revolutions similar to what you thought. And then you hope the camera took lots of pictures, and then eventually you download the pictures and get it happy and excited.
I wish I could have been there with the team to see that. It was before my time at the Planetary Society, but that just, hearing the stories from the LightSail time, you guys lived through a whole thing.
That is an understatement. Yes, no, it was a very big project for us and very challenging. And something could have gone wrong. I mean, we did as much testing as you can, but especially testing a deployment that actually happens in microgravity on Earth of a thin aluminized mylar to 32 square meters is non-trivial. So basically, you can only do so much. When we did deployments, there are also videos of that on specially built tables that would at Cal Poly San Luis Obispo, one of our partners, anyway, it worked. We had lots of exciting glitches along the way, but all of them things that we were able to deal with or that we had planned ahead for from testing on Earth. It was exciting.
I really hope that the TERP Raptor team gets enough support that they can actually make it to that point. Not that I want them to be stressed out, but to have the excitement of seeing it all finally come together after all that work.
They certainly have a great team. They have a lot of enthusiasm and a lot of knowledge and a lot of history. Brent alone has worked on a number of missions and orbital work and done all sorts of great works in planetary defense. So they've got a great chance at it, and hopefully they get the support. If they don't and they can't make this time frame, my impression last was they'll keep this money working towards some other mission. So it's good stuff. It's good stuff. Good luck and Godspeed.
Well, before we move on to our random space fact, we also have two big major space events that are coming up in the next, couple of weeks. I want to give people a little bit of warning. So, first off, I wanted to warn people about the Perseid meteor shower.
Yeah, the Perseids it's exciting this year because we are under a new moon, completely new moon for the peak, which will be the 12th and 13th of August. Usually better after midnight, but basically look anywhere in the sky. It's not quite as good if you're in the farther in the southern hemisphere, but usually the second best meteor shower of the year in terms of meteors can be anywhere from 50 to 100 an hour. With the new moon, there won't be interference from that. So I encourage people, if they can get to somewhere without clouds, because those still are a problem, and even better without light pollution, take a look. But even if you've got light pollution, if it's not the worst, and if you're patient and go out and stare at the sky, you should see some little lights streaking across the sky and not blinking. The blinking ones are airplanes.
But the fact that this meteor shower is happening during a new moon is actually really cool because it's not only great for viewing of meteors, but
wait a second. Doesn't something else happen during new moons sometimes?
Sometimes. And it just happens to be happening this time.
And what is that, Sarah?
Total solar eclipse.
Cool. So if you are in Western Europe and if you're hanging out in Greenland, you can maybe end up still on the path of total eclipse, but you'll almost certainly get a partial solar eclipse. So get excited, and we will think about you and look at it online from the west coast of the Americas or any of the Americas.
I'm a little jealous, honestly. I was talking with Andrew McCarthy, who's an astrophotographer, and we'll share this conversation later.
Oh, not the one from the 80s movies. Okay.
No, but he was talking about what this eclipse is going to be like for people. And I think it's going to be really special because it's so close to sunset. The fact that this is a total solar eclipse in a region that hasn't had one since 1999, so close to the horizon, I think it's going to be really spectacular.
Oh, they're always spectacular, and that sounds very cool.
Yeah. Awesome. We got Perseid meteor shower, and we got total solar eclipse. So August 12th, big star, shooting star, almost a random space fact, almost.
Almost, but we could find a random space fact rewind. Today we're talking again about Saturn and its rings. Saturn and its rings would almost perfectly fit between the Earth and the moon.
Oh, wow.
So they're big. So the moon is about 400,000 kilometers or 225 miles. It varies because it's an elliptical orbit. So it's all, kind of approximate, and you're taking the main bulk of the rings, but it however you measure it, they're on this similar size frame, which is kind of incredible.
That really is. That's a really great way to ballpark it in my brain, not because I have a great intuition of how big Saturn is, but because just having that visual of Earth, Moon, and just shoving Saturn between there, it's like a perfect ruler.
Yeah. Although it's hard to have a feeling for the distance of the moon or the width of the rings, it gives you an idea that certainly the ring part, I mean, that it's much bigger than I would have thought.
Yeah. Really, really big, really, really thin. That's what surprised me from the Cassini data, just how thin those rings are.
Oh, it's ridiculous. Most of the rings are about 10 meters in width, and they're measured in, here to the moon, hundreds of thousands of kilometers in diameter. There are a few places that have weird exotic stuff that's a few kilometers, but it's mostly 10 meters-ish, which is just ridiculous. You're ridiculous, Saturn rings. Cool, but ridiculous. All right, everybody, go out there, look up in the night sky, and don't think about moving. Think about rooms that are painted all red. Thank you, and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with more space science and exploration. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review and a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email, planetaryradio@planetary.org. Or, if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members. You can join us as we continue to defend Earth and support teams like TERP Raptor at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Casey Dreyer is the host of our monthly Space Policy Edition, and Matt Kaplan hosts our monthly Book Club Edition. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. My name is Sarah Al-Ahmed, the host and producer of Planetary Radio. And until next week, Ad Astra.